Thank you, Danielle. With scanning, it becomes more possible than ever to achieve design certainty. With design certainty, there are new opportunities for saving time and project cost. PMC has been utilizing scanning for 15 years and is well versed in the evolution of the technology, helping clients to avoid mistakes and pitfalls made with earlier versions. The traditional method of creating a true as-built of existing structures can be time-consuming and expensive. Rarely are accurate plans available, and most often field measurements have to be verified multiple times. Using digital laser scanning, the accurate data is captured one time and can be converted directly into the CAD model. This chart shows the transformative changes in the technology of laser scanning. In the early stages, an average of only 24 scans could be captured in a day. With the advancements of faster and lighter field equipment, the productivity of terrestrial scanning is now an average of 185 black and white scans per day. New software tools, such as Autodesk Recap, have also led to faster processing of the data. Let's examine two common types of scanning used in architecture and construction projects. Terrestrial scanning is used to capture building size and spaces, both interior and exterior, anywhere from thousands of square feet to millions. Part scanning equipment is required when a high level of detail information is required, usually for reverse engineering of specialty details. PMC has successfully integrated both part scanning and terrestrial scanning for a true vision of facilities where the capture of intricate details, such as tooling or architectural design elements, needs to be included with the facility as-built model. Today, terrestrial scanning is used in all phases of project development, whether it's fast and accurate feasibility studies or ongoing facility maintenance and operations. The challenge is identifying at what stage of the process scanning can yield the highest return for you. PMC can help. The success of a scanning project is dependent on meticulous project planning. The scope of the project is determined by the level of detail and specific areas to be captured. Ideally, scanning should take place when there is little or no activity in the facility. This might require off-shift or weekend, overnight scheduling, and access to the facility must be coordinated. A fixed project timeline and costs are agreed to before any work begins. Because of PMC's vast experience in scanning projects for over 15 years, we know the questions to ask from an AEC perspective. The details might include existing structural issues and if there are any safety considerations in accessing the work areas. Also, what will the client be modeling? For example, will there be a need to take time to capture all MEP detail, or are they only interested in the architectural floor plan? If the equipment and MEP will be removed during demolition, there's no need for the added scanning time and associated costs. This is the typical workflow for terrestrial scanning. There are always various options based upon the desired outcomes. The basic process is creating a detailed map of scan locations, then field scanning according to that plan, processing of the scans to create a point cloud, and then hand off to the design team. Once the point cloud has been created, the data is now available in a number of outputs. Using tools such as Navisworks, the data can be incorporated into CAD software, viewed in the field on tablets, or use it to visualize new design elements. Now let's review some examples of using scanning for significant return on investment. For renovation or adaptive reuse projects, the plans that are given to the general contractor aren't always accurate. In this particular example, most of the building measurements taken by the architect weren't accurate. It was possible to overlay the scan data directly on the existing CAD layout to visualize the variances and where corrections needed to be made. This saved countless hours of corrections to be made on the construction site and cost overruns. Sometimes there are issues that can't be detected through manual measurements. Because the scanning equipment will hold level throughout the building, it is possible to accurately determine variances in floor levels. It is possible to display the data in a number of formats, this being a graphical heat map showing bright red for +4 inches and blue for -4 inches. This data was very important in the remediation plan for the floors. Point cloud data can also be used as a design tool. This allows visualization of proposed changes directly on the point cloud data without modeling. Multiple design iterations can be evaluated quickly and economically. Collision detection has always been an important use of point cloud data. Proposed designs can be overlaid on the point cloud and interferences are quickly identified. These clashes are not readily detected in 2 dimensions. This example is from a project PMC completed 15 years ago. The gray background is the scan, and the piping was the proposed configuration. It is also possible to use the point cloud to create accurate demo drawings. Using CAD software, instructions for the demolition can be overlaid directly on the point cloud. This avoids time and expense required for creating demo documents. For a build to the model or IPD structured project, validation of as-built conditions can be performed during construction. Before the floors are poured or the walls are enclosed, a scan can be completed, data overlaid on the model, and reviewed during a project review meeting. With proper planning, this can be done in the same day. Any design changes can be checked for possible clashes with either existing monuments or planned changes. Scanning can also be used to facilitate the bid process with subcontractors. For remote job sites, the review meeting can be held online, eliminating the need for everyone to travel. Additionally, the data files can be posted for additional reviews. Everyone will be working with the same data, and multiple trips to the job site can be eliminated. By directly overlaying new design elements onto a point cloud, it is possible to visualize design changes without modeling. The mezzanine in the example is a model, and it is put into the point cloud of the existing shop floor to show ideal design. PMC also has extensive capabilities in modeling, from conversions of existing 2D to 3D or creation of 3D models from scanned data. Our onshore-offshore delivery model using our wholly owned subsidiary in India can greatly reduce project costs. Here is a case study that focuses on a project we completed on a building that was over 100 years old and no existing as-built drawings were available, and the field measurements were not accurate. Errors found during the course of demolition prompted the general contractor to call in PMC. We completed a deviation report detailing of existing plans versus actual as-built conditions. This picture is the full resolution point cloud data from our exterior scans. Architecture is dependent on photos of existing elements, but also requires relationships between elements. Photos can show existing conditions, but cannot determine exact relationships between the elements. During the scanning process, the digital scan is taken, and in the same position, an associated photo is taken to provide the ability to contrast and compare. The photo is actually the full resolution point cloud, and the inset in the upper right corner is the point cloud. The gray orbs are the locations of the individual scans. Because actual dimensional data is in the scan data, measurements can be taken by clicking on attributes and dragging to the endpoint. Note the vertical and horizontal measurements around the doorway. With all of the advancements in scanning over the years, it is now faster and more accurate to utilize laser scanning than traditional field measurements. This results in hard dollar ROI for the overall project. Taking manual measurements of tall buildings is inaccurate to impossible. This example is the exterior scan of a 10-story building. The scanning equipment captured the dimensional data from the ground level with an accuracy of 1/4 inch. Another challenge to this project was that the building had been abandoned for over 30 years. There was no power in the building and limited lighting. This is the scan of the elevator shaft taken in virtual darkness, looking straight up the elevator shaft. Black and white scans can be done in these conditions. Note the conduits along the sides of the shaft. None of this was known by the project team. Although the structural engineers needed to know the viability of the shaft. Because the building had been abandoned, the access to roof areas was limited for safety reasons. Using a boom, we were able to capture the data without having to physically be on the roof. Now let's examine some recent projects to give you an idea of timing and costs. The first is a manufacturing plant where the engineers had designed a new piping system in 2D, and the owner had some concerns about clearances and possible clashes with existing infrastructure. We were able to quickly scan the scope area, convert 2D documents to a 3D model, and perform collision analysis all within a few days. This allowed us to efficiently identify several problem areas, allowing for adjustments to be made prior to construction, saving the owner considerable time and expense. PMC has a long history of scanning very large facilities and regularly performs projects that exceed 1 million square feet. These projects require a much higher level of planning and coordination, but can be equally successful to the smaller projects. In this project, we scanned over 1 million square feet in the week before the Christmas holiday, running multiple teams of scanners 24 hours per day. This allowed us to complete the field work during the plant shutdown. This project is part of our work with the large manufacturing client to convert all of the factories to smart factories. The modeling portion of the project required a minimum of 16 designers for 10 weeks. With our global operations, we were able to work 24/7. With our breadth and depth of experience in the AEC sector, we have the ability to add value to a project of any size.